Dapat sirih pinang, sirih dari Pulau Mutiara. Pemanis kata, selamat datang, awal bismillah, pembuka bicara. Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about our chapter 5, vector valued function. We are from group 2. Okay, this is our group members. First one is Muhammad Harafiz Mesuko. Second one is Muhammad Amirul bin Muhammad Akmal. And the third one is Hamzah Wasim.
Assalamualaikum, my name is Amirul. For introduction, in chapter 5, we delve into the topic of vector value function and focus on the derivative of these functions. This topic explores three key aspects: the derivative rule, dot product, and cross product. By understanding these concepts, readers will gain a comprehensive understanding of the derivative of value vector and its application in various fields, including physics, engineering, and computer graphics.
Hello, my name is Hamza Wasim, narrative number BD220008. Today I will be talking about the learning targets of derivative rules. So, derivative rule, also known as differentiation rule, is a collection of formula and rules used to calculate the derivative of a function. Derivative represents the rate of change of a function with respect to its independent variable. Power rule is an example of a derivative rule, like if x is equal to x power n, where n is a constant, then f prime x equal to nx power n minus 1. Example, fx equal to x cube, then f prime x equal to 3x cube. The second example of derivative rule is constant rule. If fx equal to c, where c is a constant, then f prime x is equal to 0. If fx equal to 5, then f prime x equal to 0. These are only a handful of the basic derivative laws found in calculus. There are further rules for differentiating trigonometric, like there are more exponential, logarithmic, and inverse trigonometric functions, as well as rules for implicit differentiation and higher order derivatives. That's all for today.
Now we will look the learning target of dot product. A vector has magnitude, how long is it, and direction. Here is two vectors, direction, also magnitude. For the calculating, the dot product is written using a center dot, a times b. This means the dot product of a and b, like a times b equal to a times b times cos theta. For now, the diagram show a vector has a mag where for a is the magnitude length of a vector a, for b is the magnitude length of vector b, and theta is the angle between a and b, how long is it, and direction. So we multiply the length of a times the length of b, then multiply by the cosines of the angle between a and b. Here we can calculate it this way: a times b equal to ax times bx times plus ay times by. So we multiply the x, multiply the y's, then add.
Alright, for the cross product, we dive into the cross product, which gives us a vector orthogonal to two given vectors. We investigate its geometric interpretation, properties, and its connection to the derivative of vector valued function. The vector product or cross product of two vectors a and b is denoted by a times b, and its resultant vector is perpendicular to the vector a and b. The cross product is mostly used to determine the vector which is perpendicular to the plane surface spanned by two vectors, whereas the dot product is used to find the angle between two vectors or the length of the vectors. The cross product of two vectors, say a times b, is equal to another vector at right angle to both, and it happens in the three dimension.
My name is Hamza C. Matric number BD220008. Today we'll be talking about the derivative function. First, the definition. The derivative function gives the derivative of function at each point in the domain of the original function for which the derivative is defined. Then there is an example. Let's take the derivative of this function t cos theta t I plus et j plus 4t cube k. Now to simplify this, let's take the function of the I, j and k. To find cos theta t, we have to go for the negative theta sine and theta t. For the second function, we use the quotient rule. T from the, let's take denominator first t2, then numerator et minus et, then 2t over square of the denominator, plus if you talk about the 4t, take the square 12t square. Then now just simplify the function. Minus theta sine theta t I plus et, t2 will cancel from the t4, then you have et t minus 2 over t4 plus 12t square. Then if you go down, we will simplify the function a bit more. Minus theta sine theta t I plus et t minus 2 over t3. T will be cancelled from the t down there. It will be t cube j plus 12t square. That will be all. For the second example, we have RT equal to a plus tb plus t square c. Now we have with b, we have t with b, and with c we have t square, but with a its coefficient is 1. Now let's solve. R prime t equal to tr over d, which is product rule, equal to with 1a is essentially the 0a plus t is 1b plus with t square is 2tc, basically 2tc. Now the final answer is 0a will be cancelled plus b plus 2tc. For the last example, we have the question is RT equal to t sin t, t2, t cos 2t. Now we can use ijk or abc, but ijk is more efficient, more common. So let's just use t sin t I plus t2j, with t2 is j, t sin t with I, and with the last one t cos 2t is k. Now let's solve. R prime t equal to with sin t is 1, sin t plus t. Now vector function for sin t is cos t, so that's it for I. Now let's solve for the j, plus 2t plus for the last function k is cos, where t is 1, cos 2t plus for the vector function for cos is minus sin 2t and 2. This is for the last function. Now we just have to simplify. So sin t plus t cos t I for the first function I, this is it. Then we have for the second function 2t j plus for the last function cos t2 plus 2t sin 2t. Now we have to put the answer in the original function. So we will write it like this: sin t plus t cos t 2t and cos 2t plus 2t sine 2t. This is our final answer. That's all for today.
Alright, for now we will look the example of the product. There's a formula A times B equal to AX times BX plus AY times BY. So we just put a value in the formula to multiply a value of X and Y. Here's a diagram. The given diagram, we can determine A, B, BX, AX, AY, and BY. And the result is a number called a scalar to a vector. Now we just go to example, calculate the dot product of vector A and B. As we can see for the example, the diagram show a value of A, B, BX, AX, AY, and BY. So for the A is 10, for the B is 13, and times cos theta, which is cos 59.5 degrees. And we just solve the value of cos, and we get and multiply by A and B, and we get a 65.98, or the 66 rounded. Or we can also calculate it this way. Use the formula of AX times BX plus AY times BY. So we just put a value of negative 6 times 5 plus 8 times 12. And then we get negative 30 plus 96, and that's equal to the 66. Same like other formula, is a 66 rounded.
Okay, hi. This is the example of cross product. Okay, this tells us that the derivative of the cross product of vector valued function r and u is equal to r cross with the derivative of u plus the derivative of r cross with u. Okay, now we need to find the derivative of the cross product using these two vectors, and then on the next screen or next slide, we'll determine the right side of the equation above and make sure that they are both equal to each other. Okay, let's start by finding r cross with u. We will do this by evaluating a 3 by 3 determinant, where the first row will be the ijk vectors. The second row will be the component from the vector valued or function of r, which is t t square, uh, 2t square, and negative t. And the third row, we have t, t power 4 and 4. Okay, we will evaluating this by using the cofactor expansion method. And remember, this first 2 by 2 determinant will be formed by eliminating row 1 and column 2, which is 2t power 3, negative 4, and t power 4 and 4. The next determinant we have t power 2 and negative t and also 4. And the next one is t square, 2t power of 3, t and t power 4. Alright, now I'm going to write the result in component form. Okay, for the function for the x component we will have so for the function component we will have 8 t 8t power of 3 plus t power of 5 uh, minus 5t power of 2 and plus t power of 6 minus 2t power of 4. Okay, now we need to determine the derivative of the cross product, and we got 24 t power of 2 plus 5t power of 4 minus 10t and 6t power of 5 plus 8t power of 3. This is the derivative of the cross product or the left side of this equation. Okay, now we will determine the right side of the equation and make sure that it is equal to what we got just now. Let's go ahead and take the necessary information at the slide and continue. Notice to evaluate the right side, we are going to have to find the derivative of the vector valued function of r and u. For the value of r and u, it is just we take the just now value and so we have to differentiate the value of r and value of u. So for r prime, we will get 2t 60 power of 2 and negative 1. For u prime, we have 1 4t power of 3 and 0. Let's go ahead and find the cross product first. For the first row, we have ijk. For the second row, we have t2 t square 2t power of 3 and negative t, and the last row we have 1 4t power of 3 and 0. So you have to evaluate the same like before, and we will get 4t power of 4 and t, and also 4t power of 5 minus 2t power of 3. Okay, that is the equation for, that is the answer for r times u prime. Okay, now we will so we have to find r prime times 2u. Okay, as usual, for the first row we have ijk. For the second row we have 2t 6t power of 2 negative 1 and t power of 4 and 4 for the last row. And after the evaluating, we will get 24t power of 2 plus t power of 4 negative 9t and 2t power of 5 minus t minus 6t power of 3. Okay, so what we are trying to find now is the sum of the cross uh, value of the cross product. So we are going to go ahead and add the corresponding components. And the last value of r times u prime plus r prime times u, we will get 24t power of 2 plus 5t power of 4 and negative 10 t, and last one 6t power of 5 plus 8t power of 3. So it's proven that we got the same answer like the previous slide, and also it's proven that the right side and the left side equation uh, that is equal. That's all from me. Thank you. Okay, last but not least, in conclusion, the derivative rule, dot product, and cross product are essential concepts when dealing with the derivative of vector valued function. The derivative rule allows us to calculate the derivative of a vector valued function component-wise and enabling to analyze the rate of change of each component independently. The dot product provides a valuable tool for finding an angle between vectors and is closely linked to the derivative of vector valued function. It helps us understand the geometric relationship and alignment between vectors. The cross product, on the other hand, yield a vector orthogonal to the two given vectors and plays a significant role in determining the direction and magnitude of the resulting vector. These concepts provide us with a deeper understanding of vector calculus and are crucial in various fields such as physics, engineering, and computer graphics, where vector-valued functions are widely utilized. By, by grasping the derivative rule, dot product, and cross product, we are equipped with powerful tools to analyze and interpret the behavior of a vector-valued function and apply them to solve real-world problems. Jika ada jarum yang patah, kulit pohon jangan lekatkan. Jika ada kata yang salah, kami mohon untuk dimaafkan. Assalamualaikum warahmatullahi wabarakatuh.